Hey everyone, I'm William Morgan, and I am your host of the AI and Kubernetes show, where we dig into the wonderful and juicy intersection between the world of generative AI, or AI in general, and Kubernetes. I am privileged today to be joined by none other than Blake Romano. Blake, welcome to the podcast.
Thank you for having me.
Can you please introduce yourself, tell us a bit about where you work and why you're here today?
Yeah, so obviously, name is Blake Romano. I work at a company called Imagine Learning. We're an education company focused in the K through 12 market, building digital platforms or digital first platforms to help students and educators. I'm a staff level software engineer. And I have been focused on a lot of AI initiatives, platform engineering initiatives at the organization, and really trying to figure out how do we drive efficiency internally in our engineering organizations, and I'll say also across the organization holistically, and figuring out how do we integrate that into our software development lifecycle, our platforms that we're building, and how we kind of work overall.
Yeah, excellent. And Imagine Learning, of course, as part of that is using Linkerd. So that's how you and I got first acquainted. But for the purposes of this podcast, we'll probably talk less about Linkerd and more about AI. So you're involved, as part of your work in a variety of AI initiatives at Imagine Learning. Can you give us just kind of like the overview of like what's driving all of this? Is this like, is this a mandate from on high? Is it personal interest? Is it some mix? Is it something else?
Yeah, I would say it's kind of a mixture of all the above, right? I think organizations are getting asked to figure out how can we be more effective with our resources? How can we drive more efficiency? How can we do things faster, cheaper, more efficiently, more securely? And the world around us is kind of changing, right? Like the amount of security CVs that are coming out nowadays with all of the AI tools able to do absolutely insane things when it comes to open source software or closed source software. Um, some of the deep fakes coming out with being able to impersonate your, employer and extract different information. I think it's a evolving landscape that I think companies will be left behind if they aren't embracing a lot of these AI tools to drive their work. I also think it's part of personal interest, right? The world is changing, and I think the skills of a software engineer even 2 years ago is and should be vastly different than what the skills are today, which will probably be vastly different than what it will be in 6 months at this rate, right? With just the change of pace of everything. And I think the need for engineers to be able to move and adapt quickly with these tools is becoming more and more important, right? How I was writing code and building software and building solutions 6 months ago is completely out the window. And I'm looking at completely new flows as to how I'm working with all the different tools that either we're building internally, we're using either open source tools, vendor tools, whatever, and trying to figure out how do we integrate those in. And, I'd say the day to day of engineers now is vastly different or should be vastly different than what it was 6 months ago.
Right. So it's not just a panic that driven reaction. There's some excitement and some uh, good. There's good stuff that. Well, maybe I'll ask you. Is that good? Is it good or is it scary?
It's a little bit of both, right? I think there's some real big excitement in some of the efficiencies we're seeing internally in the organization as we've adopted a lot of these AI tools and been able to deliver code so much faster, software so much faster, new features to customers so much faster, security fixes so much faster. And it's a little risky at the same time or scary at the same time because we're trying to, balance that with some of our privacy needs, our security needs, our needs to ensure that we're building the right solutions for the right customers, for the right products, in the right ways. And we're really trying to figure out what is that right balance between building things fast, building things effectively, and building things reliably, and also ensuring that we're, meeting our obligations for security, privacy, enterprise architecture, data modeling, and all that other stuff when you're starting to build enterprise at scale.
I mean, it seems like that's always been the challenge. It's just now things are amplified, right? Now
Oh, yeah.
faster code.
Amplified
Yeah.
amplified by probably 100 times, it feels like. And it's really also interesting to figure out how are we working in teams differently nowadays, right? Where, I would have an initiative that may take 6 months, right? I can get that same initiative done in half the time, a third of the time, a fifth of the time, and potentially with a smaller team than what I, was needing for that feature work. So it's really interesting to figure out what is that right balance. And I think all of the practices we've been doing on product, on design, on engineering is so quickly evolving and changing. Um, and it's really interesting to see how, obviously us internally in our organization, but other organizations are handling that balance of, being able to move quickly and move effectively. At the same token, think about all those enterprise things, think about cost, think about reliability, security, et cetera.
Yeah. Now, let me ask you. I think the way that AI has had an impact on the developer side of things, I think it's pretty well understood, right? We've got these amazing tools like Claude that can generate code and modify huge code bases and kind of allow you to operate at this, vastly higher level of abstraction. But what about for the lowly platform engineer, right? Where your job day to day is not necessarily write code as rapidly as I can. What has the effect been for you? Has it been different from how it has been to the devs?
Yeah, I mean, I would say it's slightly different, but it's a lot of the same, right? I think the way we're thinking about platforms, and I kind of say platforms in two different ways, right? There's platform engineers in the sense that obviously we're building internal developer platforms, focusing on that intersection between infrastructure and the developer experience and ensuring that developers can build things very quickly. I think at that same token, there's also the platform side of like we're trying to build a generic platform service for how payments are handled or how authentication is handled or all that type of work too. And I would say that, where we are in the platform engineering space is still, I think now, especially coming to more of this infrastructure as code, GitOps model, having everything in source control. And that move definitely helps accelerate platform teams that are adopting those approaches. Because now that everything is inside of code, it can reference all of the things in your infrastructure based on the abstractions or the layering you've put inside of your source control. Which makes it really, really easy for us to be able to say, I need to understand how our Linkerd is configured in a given cluster, right? I can point it at our GitOps files that manage that configuration, and it can start understanding all of it. And then I can then point it with MCP to a Prometheus server that's scraping metrics, that's understanding what is the current state, what is maybe behaviors I'm seeing in my environment, and then be able to aggregate all that together to give me recommendations about how I may configure Linkerd differently. And I think it's really interesting that it's, you know, with MCP, with skills, with all these kind of concepts that have been coming out, we're able to, now extend beyond just writing code, understanding, GitOps configurations, understanding source control, and everything inside of source control and be able to aggregate all that together is really interesting.
Yeah, yeah. Now you've done a lot here. You have built an MCP proxy to kind of lock down some of the access to things like Argo and Jira. You've shipped an AI chatbot, kind of plugged into your IDP. What is how useful have those things been in practice? Where have they been on kind of the spectrum of prototype proof of concept to like, oh, this is something that our devs rely on every day and they can't function without it?
Yeah, I mean, I would say that we definitely started off with a proof of concept of, hey, we know this is a problem that's coming up, and I'll start with a AI chatbot. We were getting a lot of we were building a new internal developer platform, and getting a lot of questions from teams trying to onboard to it, understand the paradigms because there's a massive paradigm shift from how the old platform worked. And we had a lot of teams coming to us with questions. And we were a relatively small team. And we were trying to figure out how do we scale to the amount of engineers we need to support. And the answer was we couldn't. And this is when I think this was maybe when Sonnet 3 or Sonnet 3.5 was kind of the newest model. And we kind of spent an afternoon just trying to figure out how do we build an AI chatbot that understands the documentation in our platform and could answer questions based off of it. And we built a very basic prototype with AWS Bedrock and Bedrock agents and knowledge bases to get that. We had it, very rough proof of concept, probably in a day, right? Able to test it locally and validate that it was doing what we expected, which is super exciting to see. I remember, myself and my director sitting on a call, and we were like, "Oh, this is really, really cool." And if only we knew then what we knew it would come now is is crazy. But we were able to take that, right, and then be able to start scaling and figure out from that MVP, what is it getting wrong? What is it getting right? How can we improve things and just iterated on it over time. And I think one of the big things too is we were not afraid to throw it away, right?
Mhm.
We've gone through several iterations of this architecture as to what, an AI chatbot for an internal developer platform should look like, starting from, hey, let's have a very basic kind of infrastructure deployed thing, no custom code, to a lot of custom code. And now we're thinking about how do we extend that AI chatbot into, let's say the developer experience directly, right? How am I getting it into, your CLI that already is integrated with Claude Code or with, Kiro or Codex or, name the AI tool? How can we integrate, you know, some of the things that we're doing with this AI chatbot into, different workflows like Argo CD or Argo workflows. So you don't have to go to a separate UI or separate interface. It's kind of already integrated into the interfaces you're working with day to day. And so it's been a real evolution. And I would say, start small and continue to iterate on it over time. And right now it's so easy and so cheap to proof of concept something, try something out. And if it doesn't work, throw it away.
Right.
And I would say, definitely start from it. Let's proof of concept something and see if the idea even works. See if it's even something we like. And then from there, you can think about what's the long term plan of this? How do I build this architecturally sound? How do I scale this? But even seeing that first proof of concept, like it's cemented in our minds, this is something we need and there's massive value here. And I think we've been able to, reduce the time that, it takes for people to get support by, matter of hours. um, you know, we've scaled the platform to hundreds and hundreds of engineers at this point. And all of that has been really, really thanks to the help of some of these AI tools that we built and some of the developer experience stuff we built in the platform.
Now you've talked about how you evolve that, in so that it gets closer and closer into the kind of the dev's existing environment. How else has a chatbot evolved since that early prototype? Does it have you spent time iterating on like what documentation it has available or like how it interacts with those docs?
Yeah. So, it's very interesting. We started with a RAG-based approach, relying on vectorizing all of our documentation and putting that into a knowledge base that then the agent could ask, get the information from and export the data from, essentially in a nice AI way. And we've kind of evolved it now to essentially a multi-agent system. And instead of doing RAG, we're doing a lot of MCP tool calls, and letting the AI be almost way more agentic in the way it's thinking. Instead of it just having access to RAG, it now has real-time access to our documentation. So we don't have to worry about doing RAG. We rely on, our documentation's search capabilities to be able to do search across documents. It's also really interesting because we've now thought about, or we're thinking a lot more about what is our information architecture and how we're designing our documents, to make sure it is better suited for AI to be able to understand our documentation, which has become more and more important. And probably, as you know, right, developers are not the best at writing documentation. So having AI be able to supplement our documentation, evaluate what our information architecture is and how we're structuring our documentation, it's been really important. But yeah, we've definitely shifted from a very basic like agent has system in RAG to a multi-agent system architecture where, right, you could plug and play with different agents over time. You could add agents, MCP tool calls for, more real-time analysis as to, what may be happening in our Argo instance, what may be happening in our documentation, what's going on in our ticket managing system, right? And being able to extend that. And building more of a composable system.
What's like the most surprising thing that you learned in this process? Is there anything that stands out where you're like, oh, I really didn't expect that?
I'm still amazed at how fast these tools are moving. It's kind of my my big thing. I wish we had more time to dedicate to um, you know, focusing on like building these AI systems more and more. But I just think these tools are moving so quickly, so efficiently. And I would say managing these systems at scale is not easy, as especially when we move to a multi-agent system architecture, it's very difficult to manage at scale. You're talking about agents that may be off running inference for minutes at a time. How do you manage, more stateful connections in Kubernetes? How do you do that reliably when you're scaling up and down? How are you managing, let's say, a pod getting evicted while it's in the middle of inference? Who's picking up that work? Does the request just die? How do you ensure that you're maintaining reliability of those things? So, as I think about some of the vendors we use, and some of the issues that vendors have with managing these systems at scale, I kind of understand some of it. Managing these systems is very complicated. Debugging, observability, traceability, and handling when things fail is complicated in these worlds.
Yeah, yeah, I can imagine. Can you walk us through, like, what does it mean for this to be a multi-agent system? So, like, the user types in some question, and they're like, "Hey, how do I, deploy my," or I don't know, "what's going on with my pods over there," or something like that. And then you take that as input, and then you spin up a bunch of, are these literally Kubernetes workloads that are talking to an LLM somewhere else in the infrastructure and have some like system prompt, or like what does that look like?
Yeah. So, what we're doing is we have kind of an orchestrator agent that's aware of all the other sub agents that it can talk to. So, let's say the orchestrator agent may have access to an Argo CD agent or a internal developer platform documentation agent. And based on the request, it can figure out, okay, where do I need to go? Is this a question about what's happening in a deployed environment in Argo CD? Cool. Let me go to the Argo CD agent. Is this a question that needs to get reference from documentation? Okay, cool. I'm going to go ask, the internal developer platform agent. And these are workloads running in Kubernetes as deployments that can scale up and down. But yeah, essentially just networking and having access to invoke those agents as tools, essentially the orchestrator can have, and then synthesizing that information together, and responding to the user. So let's say I'm asking, hey, my S3 bucket isn't deploying, let me go figure out or tell me why it's not deploying, right? Our orchestrator agent may go to Argo CD because we're deploying potentially AWS resources through Argo CD. It will get information from Argo CD as to like what's the current state of that bucket, and it may talk to our platform documentation agent to understand what is the current state of like how you can configure an S3 bucket, and then it can synthesize that data together and say, well, you configured this S3 bucket wrong because of this reason. This is causing this error, which is why your bucket is not in a deployed state, or not in a healthy state. And so being able to layer that on top and have multiple agents kind of work alongside each other that are specialized and have specialized, system instructions and tools, and things like that have been able to allow us to kind of scale a little bit better. It's also nice because it is a little bit more composable, because if I want to have let's say my AWS agent be used in other systems, right? It's a unique thing that anyone could go use in the organization. And I think that is a really interesting concept of, how can an organization create, composable agents that then can come together and do something very specific for either a department or the organization as a whole.
Yeah, interesting. Potentially, an agent is like a part of the product, and you're like, hey, if you want to plug in your Imagine Learning agent into like the rest of your agent orchestration framework, and like, here's how you do it. Is the interface between these agents, is it always like this, is it one agent asking like an English language question to the next? Is it like, the orchestrator is like, hey, I should figure out what's going on with Argo CD. Hey, Argo CD agent, please tell me the answer to this question.
Yeah, that's been the way we've done it. Is it's just, you know, uh, calling an API endpoint, which is then invoking the LLM. We've been trying to lean very closely to a lot of the open source standards that are coming out, right? So A to A is the big one for agent to agent communication. Obviously, MCP is a big one for how do I connect to, an agent or an LLM to external data sources. Skills are something that we're now really starting to dive into, which is, you know, how can I essentially add additional context as to how we do things? is the way I think about it. And then obviously agents and system prompts and things like that are all things that we're really leaning into. Because I think at the end of the day, the agents will change, the LLMs will change, the tooling will change, and we may not even at some point have our own code that does this. We may rely on a vendor, we may rely on, um, an external service to go do this for us. But where the value is in a lot of these tools is the organizational context you're bringing into these LLMs, right? I think that's just the big key is when you're thinking about scaling AI in an organization, the AI knows a lot about, for example, the education space. But what it doesn't know is what is the imagined learning difference and all the things that we've cultivated internally to build really, really good products. And so the more context that it has to how your organization functions, I think that's the key. And so indoctrinating those things into your agent system prompts, into skills, being able to pull the context around how your organization works via MCP, like that's the key. And the harness will change over time. Today, it may be, this SDK over here, or it may be Claude code over here, but that harness could very well change. But having those core concepts, those core standards right now, uh, drive a lot of your AI efficiencies, will make it scalable, will make it so, when another vendor comes out with the next best tool, right, it makes it easy to transfer it. And spending our time bringing in all that organizational context through these open source standards means that we're not really wasting a ton of time because, we can change it as the harness changes.
And the swappability is interesting. So, if Buoyant provides the Linkerd agent, you could plug that in, or Acuity provides the Argo agent or whatever. Like you could plug those agents in to the same system. The orchestrator could be aware of them. It could make use of them.
Yeah, for sure. And I mean, even the MCP connection is a big thing, right? Um, if I can have an MCP connection to Buoyant, for example, I can use that in Claude Code if I'm, looking at my code with my Linkerd configuration and be able to have it debug things. I could hook it up to my, AI agent, my orchestrator agent, and then it could be available via, Slack or Discord or whatever you're using for communication and, however you're exposing an orchestrator agent could be available via any other CLI that your organization may be using, Codex or whatever. I could integrate that into the Buoyant Cloud UI and have Buoyant Cloud essentially just be exposing that MCP server through their own agent. And it makes it really composable and really nice. So that way, wherever the developer's working, I can kind of bring it along with us.
How do you think about quality, like product quality in this context? Because this seems like suddenly this is quite a different type of product from what a or aspect of the platform from what traditionally has been offered, right? Traditionally, the platform is like, okay, we've got to be reliable. Okay, well, we can measure that in uptime. That's like a pretty deterministic number. We've got to be secure. Okay, well, how do we measure that? Number of like exploits, or number of like security incidents we've had. Okay, if the closer that is to zero, the better we're doing there. We have to be low friction for our developers. Okay, so maybe there's like a product quality there, maybe like you can measure NPS or something. But like, if the platform is high friction, the developer like, oh, this sucks. There's usually a pretty direct, like, kind of product, like thought where it's like, okay, well, remove this step. Oh, they complain about this step. Well, see if we can automate that. But now you have this product thing, this like kind of much more qualitative measure where the devs, what if the devs like do all this stuff and then they get an answer that's not right? How do you like track that? How do you associate that with like, okay, and here's the problem, and how do you then turn that into, well, and then we have to like improve the system prompt, or we need to like do whatever.
Yeah, I mean, this is a really hard problem to solve. I think there's a couple things. One is, we've looked at, I'll say, like sentiment analysis, right? So you can kind of give a thumbs up or thumbs down on a response and say, was this answer right? Was it wrong? And kind of relying on a developer to give you feedback as to, how did it do? Is one avenue, and you will get some results. You won't get a lot, right? Because generally speaking, if the AI agent does well, nobody's gonna come back and say, "Oh yeah, let me give it a thumbs up." You'll probably only get thumbs down, and even that is questionable sometimes.
This is like
If you,
the how clean is my bathroom thing at the airport. Like, I don't want to touch that in the first
yeah,
place. And like, I would really only touch it with my elbow if it was like really filthy. I touch the thumbs down.
yeah, exactly. So that's one. And then the other thing is, we have a lot of tracking around how many deployments are things, how many deployments are happening in the platform, how many builds are happening in the platform, how many of those are failing, right? Um, how quickly is code getting delivered? Um, how quickly does it take people to create new resources in the platform? How quickly are we seeing teams migrate to our internal developer platform, build new things in our internal developer platform? And some of this is, some subjective measurements that you'll have in your organization. And some of it is objective, right? I can compare the deployment numbers from last year to this year and figure out what is the you know amount more of deployments that we're doing. I can figure out how much quicker is our resource getting deployed based on how many new resources they are and the deployments that created a new resource, how many of them, took X period of time from, let's say, PR being created all the way to it getting to production. So I think this is really just emphasizing a lot of the core like DORA metrics that you want to measure in your internal developer platform anyways. And I think this concept of like trying to track this stuff will die down over time. I think a lot of organizations are wanting to track it because this stuff does cost a lot of money, right? The LLM inference costs a lot of money. And executives want to understand what is the business value I'm getting out of spending all this money on all this LLM inference. Um, and I think some of that will die down over time as, some of the LLM providers become a little bit cheaper, that we can optimize our token usage. AI becomes better at being able to get the right context and not get the right context when it needs to. Um, we're trying to build a lot of dashboards internally around, what is our, Claude Code usage and how much are they using the tools that we've built, especially into tools like Claude Code or our AI agent, and be able to, correlate that with usage to see how effectively are these tools being adopted. If they're being adopted, how often are they being used? And then the other piece of it is what is the business value? And we're kind of right now trying to figure out, can we tag things that are done with AI or done with the help of, our internal developer platform agent and be able to correlate that to business value through our ticketing system, be able to track that, and then see how quickly or how much more quickly we're getting things out to customers based on all those metrics. But it's a challenge right
Yeah.
now, and I don't think anyone has a great answer to a lot of these problems.
What I like about this, though, is that these are fundamentally the same challenges that we have for any kind of platform. Yes, it's been amplified, right? But like you always have to justify, well, why are we spending all this money on AWS? Whether it's for, whether it says Bedrock or whether it says EC2 or whether it says S3 or whatever, like you still have to, you still have to somehow be able to tie that to, well, here's the business value that we provided. So like the core problems, you mentioned the DORA kind of metrics, like the core problems are not really different. The details have changed, maybe substantially changed, but the framework still makes sense.
Yeah, and I mean, this is kind of the core concept of like why I think organizations with internal developer platforms are doing so much better in this wake of AI than I'll say if you have the wild wild west and everyone is kind of just deploying the way they want, is we can indoctrinate how we're building things, how we're deploying things, and have all those guardrails baked into the platform. And this makes it really really valuable because it kind of protects us from if let's say AI goes and does secrets wrong and whatever, like we can build those protections into the platform, either at the build phase, the deployment phase, or even, at the code generation phase, to protect us from things like secrets being leaked or some of these other things. Um, ensure that we're establishing the right architectures and, that people aren't going off and using an AWS service that we have no idea how to support, right? Because all of those guardrails are baked into our platform. It allows us to feel a little bit more comfortable moving quicker because we have those protections, we have those guardrails, we have those best practices kind of already baked in.
Yeah, and it seems like that analogy kind of, holds to a lot of these things. Like, if someone, let's say a dev interacts with the chatbot and it gives like a totally wrong answer, you would want, what's basically kind of an equivalent of a distributed trace where you're like, okay, well, here's what the orchestrator agent did, and here's what this agent did, and here's what this did, and here's what we got back, and then here's why that decision was made, and whether that's literally like some open tracing trace somewhere, or whether that's a set of like log lines that you piece together. Like we have all those analogies already. We have the ways to think about how we characterize and debug in these distributed systems.
Yeah, and I definitely think those protections and guardrails inside of your internal development platform are going to become key, right? I know in a lot of organizations, we're seeing a lot more non-technical folks or non-engineering folks actually wanting to build code for internal efficiencies, right? Whether it's creating content faster or doing marketing better or whatever the case is, right? They may want to have, Claude or Lovable or whatever tool actually create some sort of software that lets them move faster. And part of our job in the platform space is to enable the business to move faster. At the same token, we need to have these protections and guardrails in place. And I think whether it's engineers writing code, non-engineers writing code, leveraging a platform that has all these guardrails in place, will allow us to be able to scale a lot of these internal efficiencies we're building, and ensure that they're following the best practices, that they're not doing something that's insecure, doing something that's makes other things in the platform unreliable or things like that.
Yeah, we've had a couple of good conversations on this podcast with other guests about how a lot of the protections that you have been able to, or lack of protection that you've been able to get away with for a long time in the platform level, you can't really do anymore. Like, you used to be able to say, well, this code has all been code reviewed, and like our engineers are pretty smart, and like everyone knows how security works. So, it's not the likelihood of it like deleting the database, it's probably close to 0 or very, very close to 0. There's other ways that the database is gonna be lost. It's not through devs writing the wrong code. But now you've got LLMs in the mix, and it feels like you're basically guaranteed, at some point, they're gonna find the delete database, function, and they're gonna, or tool or endpoint, and they're gonna try and call it. And so now you really have to think through, okay, what are the protections that we need? It's you've like shifted, you've kind of like inverted the threat model almost, where you're like you have to assume they're going to call these, the code's going to be running in your platform and it's going to do the wrong thing.
Yeah, and I definitely think you need some blessed paths for, I'll call people vibe coding, right? Or
Hmm.
people that don't have that engineering background now starting to write some code. You need some blessed paths, especially in your platform, to say, okay, you built a internal little app that's going to let you deal with accessibility issues in our content faster, or is going to deal with building content faster or whatever the thing is, and build some blessed paths for them to build some of these efficiencies, be able to share it within
Hmm.
their organization. And that organization won't be just engineering, right? It will be a content department. It will be a marketing department. It will be, a product department. Be able to build these tools and then let them share it through your platform.
Yeah, that's really interesting. So it almost sounds like what you're saying is one of the effects of generative AI, obviously the developers get sped up by whatever, some nice number, but also it means that writing code is now much more accessible to non-developers, and the platform needs to evolve, or is going to be faced under pressure to evolve to support those use cases just as much as the developer facing ones.
Yeah, I definitely think so. At least that's, some of what we're seeing internally, and I know other organizations are feeling that same pain, right? Your marketing department is getting asked to, build campaigns faster, build marketing materials faster. Your content team is being asked to build more content, build, state customized content and all these things. And we're going to have to move faster across the organization, not just engineering. I think developers have gotten the front of this work and bulk of the AI automation, the AI help. But other departments are now getting these asks. How do we bring design faster with us, right? Are they using things like Claude Design or Figma Make or other tools in order to move faster? How are we integrating that with the engineering side now? But then how is product also interfacing with these tools? How are they understanding what the customers need faster? How are they getting prototypes to customers faster that they can show and get, understanding in the market? Is there value in this? Is this a marketable product we can make? Is this a feature that we need in an existing product? And, all of our organizations being asked to do this. So, obviously engineering kind of got the front of this, but I think more and more departments will and are being asked to do this as well.
The frontier, the next frontier for the platform is you got the sales guy armed with Claude who wants to ship something, to the production cluster. Here you go.
Yeah.
Let's test your protections.
Yeah. And it's interesting as to what line organizations will draw on that, right? Do you want non-engineers to be able to put things in productions? Will you want them to have things that are customer facing, solutions? Will you want it for just internal efficiencies? Do you put them in their own little segment of the platform, or do you kind of co-locate them with things that are running already and that are actually customer facing things? And what guardrails in the platform are you going to need to build in order to support these use cases?
Yeah, yeah. And what happens when it goes down at 3 a.m. is, who's on the hook for getting it back.
Yeah, for sure.
Not it. Yeah. Okay, cool. Well, so how do you see this all playing out over the next couple of years? If you had to place, this is a terrible question to ask, but let's just say for Imagine Learning, you fast forward 2 or 3 years from now, like what is that glorious AI enabled platform that you've built? What's that look like at that point?
Yeah, I mean, I think a lot of it will be that we can pull in organizational context that makes a ton of sense, and make it very easily accessible to AI agents that are orchestrating a lot of this work. And now the humans are able to focus on, are we building the right solutions? Are we building enterprise architecture that makes sense? Are we scaling our data model? Are we building things that customers actually want? It'll be interesting to see what the fold is between design, product, and engineering. Does this become now one organization or one department, all working side by side with each other rather than, maybe two or three different disparate organizations? Um, because the cycle time is so much faster or will be so much faster in the future, do you need product managers in their own little world, or are they just working side by side with engineering? Engineering gets asked to do something, we get a prototype out in 20 minutes, and then we're back on a call with the product manager and design, showing them, get some feedback, and then we're coming back 20 minutes later with a new version with all their, features incorporated. It'll be really interesting to see how that evolves, but I think there will be some level of evolution there. And I would say too, I think it's going to make us really think about our abstractions and how we're building our abstractions. One of the real big challenges is that these AI models may not be aware of your abstractions around how do you create resources, AWS resources or Azure resources or GCP resources. My hope is that eventually these AI agents will just kind of have a lot of this stuff either be readily available through context, or actually, we may consider fine tuning a model or training a model with all of our organizational context in it. So it's aware when I ask for an S3 bucket, right? It knows the schema, it knows the format, and it just natively goes and builds it the way the platform is designed. I think right now the big challenge is, how do I ensure the model has all the context around how the platform works, how our organization works, and be able to scale that. So my hope is in the future, uh, AI agents become a lot smarter at that. So really now we're trying to figure out how are we orchestrating these agents to do the right things, and then ensuring that our agents have all the context they need in order to be able to go execute.
I mean, that sounds like management now.
Yeah, the
Is that
the
the
analogy.
future for us? Every platform engineer becomes a manager, a people manager of agents?
Yeah, I mean, I think the analogy I would go with, and I think this is true for developers too, even building things in a platform, is we'll become air traffic controllers, right? Managing agents that are doing work, reviewing that agent to make sure it's doing the right work, going back and giving feedback to an agent, and working very closely with our product folks, our design folks, security, accessibility experts, etc., and being able to ensure that we're building the right thing. Um, and I think that is the future. I think we are going to see engineers, platform engineers, developers, become much more air traffic controllers. And it's honestly really exciting, right? I'm now not really thinking at the micro level. It's like, what is this function doing and all the logic in this function, or how am I abstracting this one little resource? And I'm thinking much broader as to how is the platform working at a high level? How is our organization working at a high level? and being able to focus on those macro level things, it brings back a lot of the excitement of, building a platform from scratch because I'm thinking a lot more at a macro level and how all these pieces will come together and how to make a cohesive experience. And I'm less worried about, okay, do I have a bug in this function that's causing a memory leak over here, or that's causing some performance degradation over here, or that isn't secure, right? Like Claude knows a lot of this already. Um, and so I'm able to take a lot of my expertise as, in terms of platform engineering, building reliable systems and software, secure systems and software, and be able to just ensure we're building the right things and building them to scale and thinking really high level. And I think that's really the exciting piece for engineers moving forward.
Yeah, so you've been able to move up a layer of abstraction or maybe several layers of abstraction and operate at, a much higher level. That
Yeah,
totally makes sense.
yeah, for sure.
Even I, even me, um, I have deployed over the past 2 weeks, I've deployed a ton of stuff to AWS, and I have used Claude, and I've told Claude, make it reproducible, make it programmatic, make it so I can run a make file. And it there's a lot of Terraform involved, and I'm very happy to not have to ever look at that Terraform. Hey, it works, or this thing's happening. Can you fix it, please? And that, even that little experience has been really illustrative of like, yeah, like you say, you can really go up a level of abstraction and not have to worry about, oh, is my Terraform config wrong? Instead, you can worry about the higher level question is this the right architecture? Am I, do I want to partition things this way, or do I want to put this part over here and store this data over here? And yeah, that's pretty empowering.
And the next level that we're going to figure out is, how are we automating code review processes, right? I think it was yesterday I looked at probably 10,000 lines of code or trying to review everything that, engineers were outputting, and how do I scale my code review process to ensure that developers can move quickly, can build scalable solutions without having to look at every single line of code? Or can I have an AI agent be able to point me to certain areas that it thinks may need a human review, so that way I can scale myself as a, reviewer, because so much code is coming out now, right? Whether it's Terraform configs, whether it's, other infrastructure's code, GitOps changes, actual, code that's being written. And being able to scale that review process is really, really critical. Um, and well, that's a problem that I'm trying to figure out right now is how do we look to scale that?
There's one company, very heavy AI usage that I know of, where they do human code review of the Claude plan files.
Mm,
That's it. They don't review the code.
interesting.
Take that for what it's worth. Let me do that for a couple months and let me know how it is.
Yeah, that no, it's definitely an interesting model. I mean, I will say I
Kinda
think
makes
that
sense.
yeah, no, that plan phase is the most important, right? The more you get right up front, whether it's designing your product requirements, designing what the project will look like, whether it's designing your architecture, that's where if you get something wrong in that arena, you spend the most time trying to fix. If I, make a little bug that happens to go out to QA, I have an automated test that fixes it. Great, I have Claude go fix it after. Um, that planning phase is the most important. That's where, you know, us as humans and AI should be spending the most amount of time thinking about because that's the critical piece.
Right, right. Or, if you write the code this way, you'll have to refactor it, and, that'll be expensive later. Well, the refactor is not that expensive anymore, right? Especially if you have a test harness you can validate it against. Yeah, maybe reviewing the plan, and which is, basically reviewing the architecture. Maybe that's the right way to do it. I don't know.
And
We
again,
haven't shifted that model yet, but we'll see.
yeah. And again, amplifying that, you have test coverage, you have, good metrics and observability, and all these things become so much more important when you're delivering so much faster with AI, to ensure you're able to meet up with your SLAs, your SLOs, and ensure you're reliable and secure.
And what about, Blake, what about for humanity as a whole? Are we just destined for Skynet? Should we all be typing please and thank you into every LLM so that the AI has a record of that when we're up against the wall? Are we all just destined to become meat drones for our machine overlords? Or is there
Yeah,
a brighter future ahead of us?
I'd like to think there's a brighter future ahead of us. I guess what I would say is, humans have an innate ability to build creative solutions and understand things from a human sense. I think machines are starting to get good at it, but I don't think that will be replaced anytime soon. Right. So I still think you're going to need decision makers in the room to figure out what are you building? Are you building the right thing? Does this thing make sense in terms of the broader thing? At least right now, I can't transfer my brain into Claude, and all the context I have in my brain, and all the thoughts and feelings I have in my brain. So I think there is still going to be room for humans in all of this, and I think it will continue to evolve as these LLMs get better, the harnesses get better. We build new standards for the next thing, whether it's, how we manage context or how we manage knowledge bases or, whatever the thing is. But I do think there is, or at least my hope is there's a brighter future out there for humans where we, instead of focusing on these minute things of, oh, I got a bug that came in, let me go figure out what the function is that's breaking this and having even agents orchestrate that, humans are even thinking higher level as to, are we building an educational product that is solving the problems that students need or that educators, need problem solved for? And having engineers focus on that, then I got a bug that came in that is because Claude messed up a function. I think that is the future. And I think it'll be really meaningful to humans in order to live in that future.
Yeah. Yeah. Okay, one last question, and then I will let you go. But what's your advice? I think you are on the very leading edge of a lot of the kind of platform focused usage of AI. What is your advice for other platform folks who are starting to go down this journey? One thing you said, which I think is good advice, is the cost of prototype is very low. Um, are there other lessons that you would want to communicate?
Yeah, I mean, I'd say don't be scared to fail. I mean, there's so many things we've tried internally that have not worked out or that, worked for a little bit, but then we pivoted because the next, a vendor came out with a solution or, um, you know, uh, it just didn't end up working or we tried to scale it and it didn't scale or whatever the case is. Um, you know, failure is okay, right? Like we talked about, right? Refactoring code and refactoring solutions is really cheap now. So don't be afraid to build something and then throw it away if it doesn't work. Be willing to just build something really, really quick and see if it works. And don't forget a lot of the core engineering principles that we have, right? Making sure things are secure, making sure things are reliable, having tests, having guardrails in place, like all those core fundamentals, the DORA metrics, everything like that is still present. It's just amplified a lot now because of AI and because of the world that we live in where, mythos or, the next AI is going to be able to figure out all these security vulnerabilities or whatever the case is. You still need those core fundamentals and how you build software, how you build platforms. Um, and, don't lose track of that.
Blake, I want to thank you for being here with us today and sharing all of your hard won wisdom. I had a great, great time speaking with you. So thank you.
Thank you.
All right. And let's do it again.